Ethical considerations in artificial intelligence, the RadioVal project. Radiomics is an advanced artificial intelligence technology to extract meaningful data information from standard medical images, such as computerized tomography, magnetic resonance imaging, or positron emission tomography scans that cannot be observed visually in an image. The RadioVal project focuses on the field of radiomics, especially on breast cancer and on the MRI modality. The project will develop, deploy, and validate an AI-driven radiomics tool for estimating treatment response to neoadjuvant chemotherapy in breast cancer. The AI radiomics tool can improve the use of healthcare resources to meet the patient needs with regards to a more efficient treatment. Additionally, it can support the implementation of patient-tailored treatment, increase efficacy of neoadjuvant chemotherapies, while reducing any unnecessary time and resource-consuming treatments, hence minimizing patients suffering from unnecessary side effects. It also has the potential to reduce the need for genomic testing. Why are ethics important in science? Ethics are in the moral principles and values that must be adopted to bring honesty, integrity, and avoidance of error in all stages of scientific practice. All ethical concerns related to the development and use of AI in healthcare are relevant and therefore seriously considered in RadioVal. Planning ahead, RadioVal has already identified a set of guiding principles in relation to ethics that the tool's development team will follow throughout the project and beyond. Transparency is a fundamental factor when using AI. Those using the tool should be able to have access and understand the processes that govern it. Clinicians will need to acquire new skills to provide their best care when using the AI tool, to be able to identify any risks and pitfalls, to monitor the AI results and use it with justice among patients. This requires access to available and easy-to-use information that can be effectively evaluated. The process should prevent bias in decision-making and ensure that responsibility and accountability remain with the human operator. But how does AI impact the human autonomy? Clinicians may prefer to rely on suggestions produced by AI over their own judgment. Such over-reliance on machine-produced decision is called automation bias. To address the risk of human autonomy loss, the RadioVal will actively engage healthcare professionals at all stages, from AI development to its clinical implementation, in order to have their professional feedback. The RadioVal tool is not meant to be used as a final decision maker. Instead, we'll make sure that there is always human oversight. The RadioVal system will provide the healthcare professional with a suggestion, and they will use it together with their own knowledge and all the other means of diagnosis, such as blood tests or radiology images, to make their final decision. This decision will always be based on the clinician's experience, integrated with the best possible technologically enabled advice to provide the best possible treatment for each patient. Next thing to consider are explainability and interpretability. Explainability manages the risks of not revealing any information regarding the AI process of model training and the resulting bias, resembling a black box AI. In radiomics, it provides understandable explanations to a clinician and user on the mechanisms behind the AI outcomes and decision-making. The human operator must also understand why a trained model made a particular decision and evaluated the model's performance in terms of success or failure. Explainability includes both understanding the technical aspects of algorithm structure and how the outputs are presented to the end user. RadioVal will define, implement, and evaluate appropriate radiomics explainability approaches, and their usability will be assessed by clinical experts for the radiomics models developed for breast cancer treatment in clinical settings. AI has the risk to mirror human biases in decision-making or discrimination that is already present in society. Frequently, the data used to train the algorithms reflect humans' decisions, preferences, and values. Thus, AI should be trained with diverse data, keeping in mind the global community, and also promote justice while eliminating unfair discriminations, ensuring shareable benefits, and preventing the infliction of new harm that can arise from implicit biases. The radiomics AI tool in RadioVal will be tested against bias and evaluated for fairness in large-scale international studies using multi-ethnic populations, underrepresented groups, and clinical settings. In cases where biases or other AI limitations are identified, this will be clearly communicated to the users of the AI tool. Moreover, RadioVal will carry out multi-center, multi-continental, and multi-phases radiomic studies for neoadjuvant chemotherapy in breast cancer treatment, and the datasets used for training will be based on stratified variables such as age, ethnicities, breast anatomy, and clinical classification.